Alzheimer's disease is like you have this tapestry, beautiful tapestry you've created your whole life. Every choice you've made from when you were an infant, every experience you've had because of the choices you make, creates a memory. And it's recorded in 100 billion neurons and tens, if not hundreds of trillions of connections or synapses, your neural network. And all of your experience are all intertwined in this beautiful tapestry. And Alzheimer's disease comes in, and by destroying the synapses, the connections between these nerve cells, it's like they're pulling that tapestry apart, thread by thread. And as you know, when you pull something apart thread by thread, the more you go into it, the faster it starts to come apart. All of these memories you made your whole life, creating who you are and how people know you, are disappearing. It's awful for the patient who is terrified by this. It's awful for the loved ones. It removes the essence of the person. There's nothing worse. Fortunately, we're in a golden age right now of Alzheimer's for drugs being on the way, whether they're new drugs or repurposed drugs.
Welcome to Ceci, the podcast where you see what others see.
Hi there. Good morning. So today, what are we talking about? Hello? Hello? Can you hear me? Ceci here. Is anyone there? Hi, my name is Ceci. I'm based in Berlin, and I want to welcome you to Ceci, the podcast where you see what others see. This season is all about the mind. And today we'll talk about Alzheimer's disease, the most common cause of dementia. Dementia is a condition that currently affects over 55 million people worldwide and is expected to rise to almost 80 million within the next few years. And of those cases, 60% to 70% will account for Alzheimer's disease. While this is terrifying, there are brilliant and humane minds out there working tirelessly to find a cure. One such mind is our guest today, and I know you'll be excited to find out who he is.
Our guest today is Dr. Rudolph Tanzi, one of the world's most influential neuroscientists. He's the director of the Genetics and Aging Research Unit, director of the McCance Center for Brain Health, and co-director of the Mass General Institute for Neurodegenerative Disease at Massachusetts General Hospital, and the Joseph P. and Rose F. Kennedy Professor of Neurology at Harvard Medical School. He's also co-founder of the Cure Alzheimer's Fund, where he chairs the Research Leadership Group. As a pioneer in the fight against Alzheimer's disease, he co-discovered the very first Alzheimer's genes, including the amyloid precursor protein and presenilin genes, and later identified CD33, linking Alzheimer's to neuroinflammation. He also discovered the Wilson's disease gene. His lab created the groundbreaking Alzheimer's in a Dish brain organoid models, which have transformed drug discovery and are now guiding clinical trials. Having published over 750 papers, he's among the top 1% most cited scientists worldwide, is a member of the National Academy of Medicine, and has been recipient of the field's highest honors, including the Potamkin Prize, the Metropolitan Life Foundation Award, and the Smithsonian American Ingenuity Award. Named one of the world's 100 most influential people by Time magazine, Dr. Tanzi is the New York Times best-selling author of Decoding Darkness, Superbrain, Supergenes, and The Healing Self, for which he's hosted several television shows on PBS. In addition to his groundbreaking work in neuroscience, he's also a gifted musician who's recorded with Aerosmith, Joe Perry, and Johnny Depp. But beyond all these achievements, what sets Professor Tanzi apart is his relentless creativity, drive, and scientific open-mindedness, topped only by his courage, deep empathy, and compassion in combating one of the most terrifying diseases of our time.
Professor Tanzi, it's an honor and a joy to have you here with us today, sir. Welcome.
Thank you for having me. Pleasure to be here.
In 1906, a German psychiatrist, Alois Alzheimer, encountered a patient named Augustetta, whose mind was slipping away in mysterious ways. After her death, he examined her brain and discovered strange plaques and tangles that no one had seen before. This breakthrough marked the first description of the disease that now carries Alzheimer's name. Professor Tanzi, let us begin with a central question. What is Alzheimer's disease, and how do the different physical phases of its pathology appear in the brain?
Well, Alzheimer's disease is the most common form of dementia in the elderly, and in people in general. Dementia is a general term for a catastrophic loss of cognition, the ability to learn, the ability to recall and have memory, focus. So, as you mentioned, it was Alois Alzheimer's back in 1906 who noticed in the brain of a 56-year-old female patient who had early onset Alzheimer's that there were these strange lesions. He called the amyloid plaques miliary bodies. And he said inside the nerve cells, there were wispy things that he didn't know what they were, but now we know they're neurofibrillary tangles made of the protein tau. And he proposed in a symposium at Tübingen that this was causing her features, her psychiatric features. But from what I've read, even people like Jung were in the audience, and no one believed him. At that time, the idea that physical lesions in the brain could lead to mysterious mental effects was unheard of. It was really later on and over time that this was accepted, that these lesions were causing this. And for decades, we only used the word Alzheimer's disease, even when I was a student, for pre-senile dementia, meaning that you wouldn't call just regular senility Alzheimer's. And it wasn't really until the late 70s that it was noticed that people with senility had the same lesions. So now Alzheimer's disease went from some backwater rare disease of pre-senile dementia under 60 to now one of the most common diseases in the world. We can go into more detail later about how the amyloid plaques and the tangles lead to the disease and the key role for inflammation in the brain, without which you won't have the disease.
And Professor Tanzi, your discovery of the first gene of Alzheimer's disease, which produces the beta amyloid protein, was a groundbreaking moment in science. And I have various questions I would like to ask. First of all, what drew you to this research as a student? Was it instinct? And why was this discovery that amyloid triggers the disease so revolutionary?
The story really is interesting because in 1980, I started working with Jim Gusella. It's mundane now, but he had the idea back then in 1980 that you could use solely genetics, genetic analysis of families to find a disease gene, which sounds pretty common today, but had never been done. And the idea was to find variations in the human genome. So, we all have 3 million bases of DNA, like beads on a string. But every 1,000 bases or so, you have a different base or bead than I do. And the idea back then was to find the most common variations in the genome across people and use those to track inheritance through a family and say, can I find a variant in the genome that tracks perfectly with the disease status? So let's say you have 5 kids in the family and 2 of them get variant A and 3 of them get variant B, and the 2 who got variant A got the disease. So we did this for Huntington's disease. We were miraculously lucky because we picked out the 12 first variants ever shown in the genome. Now we call them SNPs, or single nucleotide polymorphisms, or variants. So think about it as 23 chromosomes. They're like haystacks of different sizes. And we picked out 12 pieces of hay. trying to find a pin, trying to find a needle. 2 of those pieces of hay were needles. It was miraculous luck. I actually picked them, so it was my lucky hands. But that was the first time a disease gene was ever found using genetics. And every year, I nominate Jim Gusella, it was his idea, it was my hands, for the Nobel Prize for that, because that started the entire human genome project. So later, I wanted to build the first full map of a chromosome, a human chromosome, just using these variations, just a variation every spaced along the chromosome. I picked chromosome 21, number 21. Why? It's the smallest. I could get it done fastest. I was a student. And when I started studying chromosome 21, and I became, as a young guy, kind of the go-to person for the chromosome 21 genetic map, I was approached by many people studying Down syndrome. Because in Down syndrome, you have an extra copy of chromosome 21. And I read an article in Science one day, I think it was 1984 or so, as a young student, that every Down syndrome subject goes on to get Alzheimer's pathology. And then a paper came out right after that from George Glenner. George Glenner created what's called the amyloid hypothesis of Alzheimer's. And he figured out what the amyloid plaques that, Alzheimer described in 1906, he figured out what they were made of. And he called the small protein that makes them amyloid beta protein. He suggested that amyloid was causing the disease, causing Alzheimer's disease. And I met him. He was an amazing guy, chain smoking Marlboro cigarettes, gruff voice. He said, Rudy, you got the chromosome 21 map. I'm sure there's a gene there that causes the amyloid, and that's why the Down syndrome subjects get amyloid. Find that gene. And I went for it. And I have to tell you that the heads of my program at Harvard told me I was crazy, that I was chasing a tin can and a garbage heap, that this was not a good thing for a student. It was too high risk. I didn't listen, luckily. And sure enough, in the summer of 86, found the gene that I named amyloid precursor protein, APP. That was the first Alzheimer's gene.
Amazing, amazing. And why was it so revolutionary, this finding? What does it lead to afterwards when you found this gene?
Well, the big change, the so-called paradigm shift, was that people assumed that the amyloid plaque in the brain, this sticky material like a boulder sitting outside of nerve cells, was just a big garbage heap, just a junkyard. And when I showed the heads of my program at neurobiology at Harvard that I wanted to go after the gene that makes this little peptide that this guy, George Glenner, found in the plaque, they said, well, look, he published his paper in the lowest journal there is. Everyone knows the amyloid plaque is just a bunch of junk. He probably just found one tin can, and you're going to find out who threw out the tin can. And it's not going to mean anything. Well, they were wrong. And Glenner was right. The whole plaque was those tin cans. And sure enough, that little small protein came from a larger protein. So that was one paradigm shift. Then we learned that this larger protein, picture 750 beads on a string, and then picture in the middle of that stretch of 750 beads, there are about 40 of them of a different color, and you need to excise it from the beads. So you clip on the left and you clip on the right. Now we knew that's how amyloid beta protein was made. It was excised from a bigger protein called the amyloid precursor protein that gets clipped by 2 enzymes. And to this day, now we know what those enzymes are. And now the most promising drug in the field for treating this disease is targeting one of those enzymes that does the clipping, and I invented that drug. We're waiting for the FDA in the US to tell us whether we can start our first trial. It took 25 years of development and $40 million from the NIH and foundations to get to this point in my lab where now we're waiting for the FDA to tell us, can we put this drug in trials that controls that clipping that makes the amyloid beta protein?
Amazing, amazing. And I want to ask you, can Alzheimer's be predicted even if it's not yet amyloid in the brain?
Well, yeah. So here's the rule. If you have a family history where the disease is striking under 60 years old, especially under 50 years old, and there's multiple first-degree relatives with the disease, siblings could be first cousins, uncles. If you see that, the odds are high that you have a mutation in that family. You have a mutation that is an early onset familial Alzheimer's disease mutation. And there are 3 genes. The first one we just talked about, APP, amyloid gene. And then in 1995, together with 2 other scientists, I discovered the other 2 early onset familial genes called the presenilins, presenilin 1 and 2. Those 3 genes contain about 300 different mutations, which if you inherit any one of them, you're guaranteed to get the disease by 60 years old. And they only account for 1 to 2% of Alzheimer's, 1 to 2%. So in that case, if you have one of those mutations, you know you're going to get the disease, and you can predict the age at which you're going to get it pretty closely, whether it's in the 50s or 40s. And in some cases, there's a family in Germany where they get it in the 20s with one of those mutations. I'll just say that the drug I was just talking about that we invented, called the gamma secretase modulator, or GSM, will fix that mutation. If you inherit one of those mutations, our drug will reverse it. So it will be a godsend for these people who have otherwise a prison sentence for this disease. That's why we're pushing so hard to get it into trials.
Wow. These enzymes will cut the amyloid precursor.
The 2 enzymes that cut the precursor, amyloid precursor, to make amyloid are very common enzymes. I mean, you need them. They have a bunch of things that they cleave. You can't just hit them with a sledgehammer.
Yeah.
And that's the mistake that Big Pharma made. They all followed each other, copied each other, trying to hit these enzymes with sledgehammers.
To just wipe them out.
And they caused huge side effects, and all the trials after billions of dollars are canceled. My late colleague, Steve Wagner, and I said, let's not use a sledgehammer. Let's use the watchmaker's screwdriver, right? Just tweak it. And it took 25 years to figure out how to do this safely, to just tweak the enzymes so that you make less of the amyloid. But we did it. And the drug we have, if it's safe, and the FDA agrees with us that it's okay, we'll be in trials by the end of this year. And if that drug works, 2 things will happen. These poor people, that's the 1 to 2% of Alzheimer's who have a guaranteed prediction for this disease by 60, will start taking this drug early in life, and it reverses what the mutations do, whether it's the APP mutations or presenilins. Now, for the average person, let's say you carry the APOE4 risk allele, right? 25% of the population carry what's called ApoE epsilon 4 or ApoE4 risk allele. It's a common variant. If you carry one of those from one parent, it increases your risk for Alzheimer's 4-fold, but doesn't guarantee it. If you carry 2 copies, each parent gave you an ApoE4. Now your risk goes up to 14-fold. But again, it doesn't guarantee it. But they are like kind of the next stage of, you can predict that there's a good chance they're going to get the disease even before you know there's amyloid in the brain, right? It's the second tier of genetics. So for them, if our drug is safe, they would use it like people will find out they have high cholesterol.
Wow.
Or have a family history of heart disease, like me, and start taking a cholesterol drug or drugs early in life to manage the cholesterol and stave off heart disease decades later. I see a future where our drug will be used like the way we use statins to prevent heart disease and manage cholesterol, but we're going to manage amyloid in the brain early in life so that you never get to Alzheimer's. We nip it in the bud. That's the vision we have, and we're on our way. It's really exciting.
Well, yeah, that's exciting. And this is such a positive note to start with this difficult subject for an interview. You just make me happy. When can Alzheimer's be detected before symptoms appear? And what criteria and methods? Of course, you just named genetical. But what other methods are available for diagnosis?
Yeah. So we divide them up into early prediction. That's where you look at family history and genetics. There are 100 different Alzheimer's genes now. So I direct the Alzheimer's Genome Project for the Cure Alzheimer's Fund. Most of those genes just increase your risk. They don't guarantee the disease. In that category, ApoE4 is the biggest. Then you have the early onset genes that predict guaranteed risk. That's only, like I said, 1 or 2% of cases. The next stage is early detection. And that's available right now. There's a blood test that will allow you to know if you have amyloid in your brain right now. It was developed both in Europe and in the US. It's called p-tau, lowercase p, tau 217, p-tau 217. What it is a protein that's released from the brain into the blood, and it tells you one thing. You just made neurofibrillary tangles. Remember, as Alzheimer said, these wispy things that choke the nerve cells from inside, we call them tau tangles. The p-tau 217 levels, if they're too high in your blood, tell you that you're making tangles in your brain because there's amyloid. The amyloid's like a match, and it lights the tangles like brush fires that spread.
Mm-hmm.
Now, you can get tangles from playing too much football, hitting too many wet, soggy soccer balls every weekend, like I used to do, or boxing, or playing American football. Bangs to the head can also cause tangles, but that would be a different p-tau that you would see.
Mm-hmm.
So we have a test to say you have tangles forming, propagating in your brain because of the presence of beta amyloid. You're on your way. And it's not until tangles in the amyloid trigger the inflammation in the brain that you get enough nerve cell loss and synapse loss to get the disease. So those are the three pathologies: plaques, tangles, inflammation. We can tell you if you have plaques and tangles. We don't have a great blood biomarker yet for neuroinflammation, but we can at least tell you if you're on your way.
And for these two phases, where you see that there's these tangles and until there's the neuroinflammation, these stages of the illness, what kinds of interventions are now currently available?
Right. We only have approved drugs in US and some parts of Europe, I think in most of Europe, for the amyloid, right? So we have what are called monoclonal antibodies or immunotherapies. You get an IV injection of an antibody where some of it gets into the brain, not much, but some of it. And that antibody finds the amyloid and binds to it. And that antibody at the same time tells little cells in the brain called microglia to eat the amyloid. So within a year or two, with routine IV injections of this monoclonal antibody, you will most likely clear your amyloid out. You blew out the matches. Now, the tangles that already formed, the brush fires, they're going to keep spreading. If there's inflammation, it's going to keep going. But you kind of clean the slate so that matches that are going to set future brush fires of tangles have been blown out. And as a result, that kind of stabilizes cognition a bit. You go downhill cognitively more slowly, if you have these immunotherapies. So that sounds great, but there's a downside. They're ridiculously expensive, over $50,000 per patient per year, partly because they're not very safe. A large percentage of patients, especially those who carry the ApoE4 double gene, which is like 5 to 10% of patients, this treatment can cause swelling in the brain, called edema, or microhemorrhages. Now, luckily, if you're on this treatment, you have an MRI every month or so to tell you, is my brain swelling? Do I have a microhemorrhage? And if you stop at that point, it's reversible in most cases, 99% of cases. But think about how awkward. Let's say if everybody in the US had the blood test, how many people who don't have Alzheimer's symptoms now, don't have any clinical symptoms now, would find out they have plaques and tangles in their brain? The lowest answer I get from people, because we don't know the real answer yet, we haven't done it, but the prediction on the low end is 10 million people versus 7 million patients. And the high end, some say as many as 50 million people. So imagine if everyone got this blood test. Right now, it's not covered by insurance because it's not actionable. We don't have a drug that's safe and affordable that anybody could take if they find out they have amyloid, right? That drug's only approved for early stage, the monoclonal antibodies are only approved for early stage patients who have amyloid. If you're just somebody who says, I got the test, my blood test says I have amyloid, you won't get that treatment. But 50 million people in this country, up to 50 million, might need it. And if we have a safe, affordable drug that hits the amyloid early in life, the way we hit cholesterol for heart disease, we can almost eradicate this disease. That's why I'm hoping my drug that is exactly for that purpose.
It's the GSM, right?
GSM, yeah, gamma secretase modulator. So the gamma secretase is the enzyme that makes the second clip of the amyloid precursor protein to release the amyloid beta. That's the one that we mediate with this enzyme. And it's very simple how it works. The amyloid beta protein comes in different sizes. The smaller ones prevent amyloid. The longer ones drive amyloid. All we do with our drug is just drive shorter amyloid beta peptides that don't form amyloid and block it rather than the long ones that make it. And the early onset familial Alzheimer cases, all those mutations, they simply make longer amyloid beta proteins that are more prone to amyloid. We just reverse that and cause the production of the shorter ones. It's very simple. It took 25 years to get here, but it's a very simple idea.
This is so amazing. So we talk about now early prediction, early detection, early intervention. I was thinking about this and I was reading and I thought, yeah, but the next step is to make all these diagnostic and curative methods accessible to everyone for these amounts of people that you are talking about. And I was thinking about this, but then I kept reading, and then in this respect, Professor Tanzi, your lab succeeded once more. Can you talk, please, about Alzheimer's in a dish?
Yeah.
And what does this immense breakthrough means for finding cures for the disease and in general, in terms of democratizing medicine for all?
Yeah, thank you for that question, because it's very important. So when I first got into this field, let's say you wanted to repurpose a known approved drug and say, what if this drug that's already safe and on the shelf in the pharmacy might stop amyloid or tangles? If you wanted to test one of those drugs, you had to do one at a time in Alzheimer mouse models. And each experiment took a year, and you had to use, dozens of mice. So we couldn't really rapidly screen every known drug to say what's already out there that might work. We couldn't screen natural products that are safe to say what works. So in 2014, my colleague Do-Yeon Kim, brilliant guy, and I published in Nature Alzheimer's in a Dish, technically called a 3D neural cell culture model of Alzheimer's. 3D because instead of growing the brain cells in liquid, you're growing them in a gel-like matrix in 3D because the brain is jello. I mean, our brain is 3 pounds of gel, right? And it turns out that if you take human stem cells and you turn them into neurons and you turn them into the glial cells and you mix them together in the gel and you put the mutations in there that cause Alzheimer's disease and you wait. Well, I remember Drew came into my office and after 4 weeks, the dish was going. He said, for the first time, we have plaques. We have amyloid plaques in a dish. And I said, that's great. How about the tangles? And he said, I'll be back. And literally 2 weeks later, he comes in. Now it's 6 weeks into the experiment. He said, we have tangles. I said, okay, block the amyloid from forming with these enzyme inhibitors that prevent the amyloid beta and see if we stop the tangles. He came back. Yep. You stop the amyloid, you stop the tangles. So in one fell swoop, we had a model for Alzheimer's. We could recreate the plaques to the tangles, and then we added the microglial cells too for inflammation and the astrocytes for inflammation. What takes, on average, 22 years in a patient from the plaques to symptoms of Alzheimer's. On average, 22 years.
To the neuroinflammation.
Yeah, from plaques to tangles to neuroinflammation to enough cell death to get clinical symptoms of dementia. That's on average 22 years. We got that to happen in 6 weeks.
My God.
And a mini human brain organoid the size of a piece of rice sitting in a tray with 96 wells where each well is the size of a paper punch. So now, instead of one drug at a time in mice for a year, we could do hundreds at a time in each plate in 6 weeks. So when this came out, the New York Times article predicted, this was in 2014, and this discovery got us every award in the book, Smithsonian Ingenuity Award. It got me on the Time magazine top 100 most influential people list. Like, people realized how big this was right away. But the New York Times predicted this should make drug discovery 10 times faster and 10 times cheaper. Well, they were wrong. It made it 100 times faster and 100 times cheaper. So with the help of the Cure Alzheimer's Fund, who funded the original Alzheimer's in a Dish, as we call it, the next 7 years, we screened every known approved drug, 4,000 different natural products to ask what's already out there that's safe and affordable that we never knew could stop plaques or tangles or the inflammation. We finished that study. We have over 300 known approved drugs and natural products that either stop the plaques, the tangles, or the inflammation. And now I'm packaging those into combinations. And I just raised at Mass General Hospital a $20 million matching fund from a foundation where anybody who donates, $1, they'll match it with $1. And we already raised, I think, $8 million. So we already have $16 million to start the clinical trials in the patients. So at the Genetics and Aging Research Unit that I direct, we developed the drugs and the DISH model and all that. And then at the McCance Center for Brain Health that I also direct, that's where we do the clinical trials. And we already started our first one on a combination of two natural products that clear the amyloid away from the brain, just like the two new approved drugs, but, much more safely and affordably, but also tamp down and stop the neuroinflammation. That trial, we just got the FDA approval to start that trial. Two natural products to do that are safe, affordable, and if they work, can democratize early detection, early intervention. So that's why I'm not retiring yet, because I've never been more excited.
No, please don't. Please don't.
When we discovered those Alzheimer genes, back when I was a kid, I thought this was the peak, but that pales compared to what's happening now. I'm seeing the light at the end of the tunnel. Very excited.
Oh, this is so exciting. And also for Professor Du-Yoon Kim, we salute him. Thank you so much for this, for all of this. To give our listeners a bit of context about how microglial cells behave, we're going to play a short explanatory clip. It uses a metaphor inspired by Shakespeare's Macbeth. And we're going to also hear one of the scenes where a loyal defender of the king slowly turns into his delusional killer.
Once, Macbeth was the steadfast guardian of King Duncan, a warrior whose blade rose only in defense of his king. But one whisper changed everything, a prophecy promising him the crown. That single spark twisted his mind. Once his ally, his mind turned traitor, feeding illusions until loyalty curdled into betrayal. And when night fell, the faithful protector became the hand that struck his king, a loyal heart undone by its own mistaken vision.
Is this a dagger which I see before me? The handle toward my hand. Come, let me clutch thee. I have thee not, and yet I see thee still. Art thou not fatal vision, sensible to feeling as to sight? Or art thou but a dagger of the mind, a false creation proceeding from the heat-oppressed brain? I see thee yet, in form as palpable as this which I now draw. Thou marshalst me the way that I was going, and such an instrument I was to use. Mine eyes made the fools of the other senses, or else worth all the rest. I see thee still, and on thy blade and dudgeon, gouts of blood which was not so before. There's no such thing. It is the bloody business which informs thus to mine eyes. Now, O the one half-world, nature seems dead, and wicked dreams abuse now the curtained sleep.
Microglial cells are the brain's housekeepers and defenders. They clear debris, help new connections form, and fight off infection. But they can also switch roles from caretakers to killers. When they ingest dead cells rather than amyloid, they assume the brain is fighting an infection and launch an attack. It's the brain's Macbeth moment. Just as Macbeth mistakes a vision for reality and sets his own downfall in motion, microglia misinterpret what they encounter. Loyal guardians become misguided warriors, and good intentions spiral into destruction.
the challenge, as I understood when I was reading, is to reprogram the microglial cells, keep their protective housekeeping role, while boosting their ability to remove harmful plaques and restore balance in the brain. The question is this possible? And you were talking already, I think it's maybe these drugs that is coming that could reprogram these cells. And if yes, how close, or maybe it's this drug that you already mentioned, are we going to be achieving precise target approaching humans?
First of all, the Macbeth analogy is brilliant. That's so cool. I hope you don't mind if I use that in my lectures. So just to reiterate what we heard, these microglial cells, they're your housekeepers. They not only get rid of toxic debris like amyloid every day and night, but they also prune your synapses. So all day you're taking in new information, and depending on what you prioritize that you want to remember based on repetition, you have all these synapses, connections. And the microglial cells also go in there and prune synapses you want and need versus on strengthening and repetition versus ones you don't need. But while they're cleaning up, as we heard, they're not just housekeepers, they're sentinels. While they're cleaning up, if they eat a microbe, like a virus or bacteria, they're like, infection. The brain's a closed system. Wipe out this part of the brain so it doesn't spread. That's what inflammation does. If they eat dead nerve cells, it's the same signal. They don't ask why those nerve cells died. They interpret that as an infection, just like the delusion of Macbeth. And now they start killing. So very simply, our first trials we're doing at the McCance Center are reprogramming microglia to be better housekeepers, eat more amyloid up, chomp it up, eat it faster, clear it up. And on the other hand, it's telling them to stay chilled out, keep calm and carry on. If you're eating dead cells, don't worry. It's only a delusion, right? It's like telling Macbeth, don't pay attention. It's only a hallucination. There's no infection. Just keep cleaning. Don't start killing. So that's our combinations. Our first combination of two natural products in a clinical trial. One gets the microglial cells to suck up more amyloid. The other one says, as you're doing this, don't become inflammatory. Don't switch over from housekeeper to killer. Stay calm. So basically, we're reprogramming the microglia. And because we're using really safe, affordable, known drugs and natural products, if we find something that will do this, think about it. Somebody could get a blood test, or they have let's say they have a strong genetic predisposition, or otherwise they get a blood test that says, I'm starting to make some amyloid and tangles. You take this combination of very safe, repurposed drugs or natural products, whatever ones work best. And now you're getting your microglial cells to eat up your amyloid and get rid of it safely, affordably. And just in case, while they're eating and they want to become inflammatory and cause cell death with inflammation, it says, no, don't do that. Just stay calm and stay a housekeeper. Don't turn into a killer. So that's exactly our drug program. That's exactly the clinical trial program. We call it pre-AD, which is early prediction of Alzheimer's disease, early intervention. We have 30 combinations that we're testing. Each trial costs about $2.5 million to see if it's working. Can we see in a patient what we saw in the Alzheimer's in a dish? And we raised enough now to do the first few trials, but we won't stop until we raise enough to do at least a dozen trials. All we have to do is hit one, Ceci, and then we go to the FDA and say, let everybody have the test. We have a safe, affordable way to make it actionable and stop the amyloid and tangles in its tracks once you know that it's starting. Or for those at high genetic risk, let's start doing it now. So that's the clearance of amyloid and the stopping of inflammation. The other drug I mentioned, the GSM, turns off the tap. It stops the production of the amyloid. Okay, so the GSM turns off the production. One of the microglia drugs unclogs the drain, gets it cleared out. And the third one prevents any water that overflowed in that sink from doing damage, the inflammation drugs. So I like to use this kitchen sink analogy. Turn off the tap, unclog the drain, just in case that overflowing sink is causing damage. Stop that possibility too. That's the inflammation.
What are the biggest challenges your lab faces in selectively reprogramming the microglial cells without affecting their essential protective functions?
The biggest challenge is that there are cells in the blood that are the analogy of the microglia in the blood is monocytes. So below the neck, as soon as you get an infection, these macrophages and monocytes, as they're called, go in and start killing the intruder, right? Well, even though microglial cells are different than monocytes in the blood, they share many of the same proteins and they're regulated the same way. So you have to be careful if your drug is totally turning off the ability of microglia to fight an infection. And that also pertains to the monocytes in the blood. So now they can't fight infection. You can get into trouble. So that's, again, why we want to use known drugs that already have had millions of empirical days of use, or natural products that already had millions of days of use, where we know there was no problem with them. We know they're safe. We know they get into the brain. Because otherwise, I mean, I could design drugs that just completely stop microglial cells from becoming inflammatory. But the odds are they're going to also stop the monocytes and you lose your immune protection in your body. That's why, again, we're focusing on these safe, approved drugs and repurposing them in natural products that we already know don't cause that issue.
And how close are we to achieving, are you to achieving a precise targeted approach in humans?
Well, we have 12 combinations that reprogram the microglia, clear more amyloid out of the brain, and to prevent the neuroinflammation. The first trial has already started. We've raised enough for that. We have enough money to start 2 more trials. And as soon as I raise, $10 million more, I'll have a dozen shots on goal, so to speak. And I only have to hit with 1 or 2 of them to have something I can go to the FDA with and say, I have a safe, affordable way to democratize early detection, early intervention in those who need it, whether it's due to family history and genetic risk, or they had the blood test and found out they're on the way to the disease.
Well, donors looking where to donate, you've heard. Professor John Crying is Vice President for Research and Innovation at University College Cork and Distinguished Professor in the Department of Anatomy and Neuroscience. His groundbreaking research focuses on the gut-brain axis and how gut microbes influence stress, psychiatric and immune disorders, and their impact on mental health, positioning him as a leading figure in this field. Let's hear him explain the importance of nutrition and good balanced diet in regards of brain health.
I think it is important that we say we need a revolution to really get people to understand that the importance of the microbiome is in all aspects of health, but in particular in relation to mental health. And I think that's an important message to get across. We spend so much time in medicine talking about genetics, when really all you can do with genetics at the end is blame your parents and your grandparents. With your microbiome, it is really potentially modifiable and offers our patients agency over their own healthcare in ways that we would never have dreamed of. So it's an early revolution, and I hope it can lead to some changes in how we think and contextualize brain health. There's things we can do, there's things we can add to our diet so we can really increase the amount of fermented foods and fiber overall. So this is the prebiotic. So both fermented foods, in some places the culture isn't as strong. In Ireland it's really poor, but in parts of Germany it's much stronger. But like things like kombucha, kefir, kimchi, the 3Ks as I call them, are really good. But also yogurts and sauerkraut and various other things are really good, and the fermented foods. But fibers are king. If you can tolerate fibers, that's really good. Polyphenols, these will give a lot of our vegetables color. Anything with color is really good, just simplistically. But also these polyphenols are in nuts and in aspects of red wine in small moderation. Also grape juice, just as good. And then we also know that omega-3 fatty acids are also good for the microbiome. Then on the negative side, things to avoid, which is really the things that are found within processed foods like sweeteners and preservatives. The ultra-processed foods in particular have been shown to be really negative for the microbiome. In general, we should try and support breastfeeding as much as possible. It is absolutely amazing for the infant's microbiome, and that's really important. We should increase our public health literacy around C-section, and we should try and avoid stress. The sleep field is beginning to wake up to the microbiome, and we really begin to see a lot of interactions between good sleep and the microbiome. We also encourage aerobic exercise in the microbiome. It's really important there. And then I guess finally, one that my kids were delighted when I told them was that having a pet, particularly having a dog, is shown to be really good for your microbiome. So that's another practical aspect.
Well, as we see, there are things that we can do today to take care of our brain. And I think there's a book coming soon titled with the acronym SHIELD, of your autogen. Adding to what Professor Krein said, could you please tell us about SHIELD?
Well, first, let me say that I couldn't agree more with Professor Krein. That was excellent. But I will put in a word for cats. I have 2 Siberian cats. So there are cat people and dog people. And I will say for genetics, I just want to make the point that just because you have a genetic predisposition or family history, in 98 to 99% of genetic predisposition, lifestyle does matter. And lifestyle can offset what you inherited. It's only that 1 or 2% of the familial early onset that we need. We're going to need a drug to help with that. The drug, for example, we're developing, the GSM. So what do we do then? How do we offset our genetic risk? How do we just keep our brains healthy, preserve and promote brain health? How do we help stave off this Alzheimer's disease? When I wrote my 3rd book, actually my 4th book, The Healing Self in 2018, I had an action plan for minimizing inflammation in the brain and clearing amyloid. And then I turned that into an acronym, SHIELD, where S is for sleep, H is handling stress, I is interaction with others, staying socially interactive, E is exercise, L is always learning new things like your listeners are doing now, and D is diet. And I am writing a new book on SHIELD, the title to be determined, but I just did a book deal with Random House Penguin to do that. And so, another thing to do, write a book. But I think of the letters in SHIELD, I want to emphasize, Professor Krein, D is the biggest, diet. And I say this because we always have heard the adage that what's good for your heart is good for the brain, because vascular disease can lead to stroke, and that can also increase risk for Alzheimer's disease. But equally true now, we can say what's good for the gut is good for the brain. You have thousands of bacterial strains in your gut that make up trillions of bacteria, and some are better than others. Some are more helpful than others. In Alzheimer's disease, the helpful ones go down, the more detrimental bacteria go up. And if you take a probiotic, and I do mine with yogurt. I had mine this morning. I had yogurt this morning. I'm vegetarian. I have it in coconut milk rather than milk. It actually tastes quite good. And I picked the yogurt to have the bacteria that we've learned are lost in Alzheimer's. Those are probably the ones you want more of. So I picked my yogurt based on those bacteria, which are bifida bacteria. And I have a prebiotic, which is granola, just a really good organic, non-GMO granola. And now you get the prebiotic with the granola and you get the probiotic with the yogurt. Okay. I'm just not a kimchi or kombucha guy. I can't do the 3Ks. At some point, I met Dean Ornish. Dr. Dean Ornish is famous for his cardio diet. And he wanted to do a lifestyle intervention for Alzheimer's disease. He was basing it on his book, Undo It, which has very similar recommendations as SHIELD. So we designed this trial capitalize on SHIELD and especially the diet, plant-based vegan diet in his book. A plant-based vegan diet, high in fiber, is the best thing for your gut microbiome. And we did this trial, and we monitored sleep, we got them to exercise. I created a device with glasses with light and sound that it's like instant meditation. It gets you down to a theta frequency, like relaxation, but you don't have to know how to meditate to do it. It's just glasses that do it. It's called Sync. SYNNC. We're just putting those out now. They're not on sale yet, but I decided after this trial to put them out there because they work so well. But the main thing is we delivered vegan, plant-based diets, 20 meals and snacks for the patient and the spouse every week. So we knew what they were eating. That was the one thing we knew for sure. We didn't know how much they were sleeping or exercising or using the meditation classes or going on the Zooms for interaction and learning new things. But we knew what they were eating. And it was a small trial, Ceci. It was only, 50 patients for 20 weeks. But the results on cognition were better than the 2 newly approved Alzheimer drugs I mentioned earlier, the monoclonal antibodies. Now, because it's a small trial, it could be a fluke. It could go away. 50 people, 20 weeks, who knows? But the larger trial is now going. And at the McCance Center, we have a brain nutrition lab where we actually study what exactly is good for the brain and your nutrition. Not only the gut microbiome, but which vitamins. We focus, as you heard, on omega-3 fatty acids, on the B vitamins, the D vitamins. Gene Bowman is our naturopath who is not only our clinical trial director, but he's also runs this brain nutrition lab. So it's a big part of the McCance Center. And we'll be doing trials on what are called synbiotics. SYN, synbiotics, is adding a prebiotic like fiber, to a probiotic. And we've been testing those in mice with amazing results. We can basically remove plaque and stop inflammation in Alzheimer's mice simply with a symbiotic. That is not that different than from what I had for breakfast this morning. But of course, in this case, you're adding the bacteria and the specific forms of prebiotic. So I'm really, really excited about the prospect of using the gut microbiome and affecting gut microbiome health to get to brain health through diet. Now, people say, I can't be vegan. I can't be plant-based. I like my this and that. And I say, don't worry about that. Stay away from processed foods and junk foods. No matter what you're eating, do try to minimize the red meat that just rots in your gut. But every day, have some vegan plant-based food, high in fiber, fruits, vegetables, nuts, seeds, whole grains, right? As we heard, colorful things that carry antioxidants, the phenolics. Every day, have some of those multiple times, like medicine. Just think, okay, I'm eating what I want, but I'm going to take a vegan break every few hours, 3 times a day, because that's medicine for my brain. I take care of my gut, I take care of my brain. You don't have to be solely vegan like me. Actually, I'm vegetarian. I'm not fully vegan because I do have dairy once in a while because I love pizza. But mostly vegan.
Okay.
Hi, we would love to hear your comments and learn about what you see. Share your input at www.ccpodcast.com and follow us on social media. Oh, I almost forgot. To accompany us in this season's journey, don't forget to hit the subscribe button. And now let's continue with Ceci.
We heard before the opening lines of Macbeth, Act 2, Scene 1. When we think about Shakespeare, I think the first line that comes to mind is Hamlet's "to be or not to be." That is the question. These words have echoed through the centuries as humans have contemplated existence and the unknown. There is a haunting parallel with these words in Alzheimer's disease. One of the most terrifying things about Alzheimer's is how it silently begins to blur memories, one by one, ultimately devouring a person's sense of self. Could you describe what it feels like for a patient to lose his or her memories as a result of this degenerative process in the brain? And in that sense, my question would be, why is it not only the sense of self, but the sense of time and space lost? How does this unraveling of memory relates to the deeper experience of identity?
That's a big question. I like to say that Alzheimer's disease is like you have this tapestry, beautiful tapestry you've created your whole life, right? Every choice you've made from when you were an infant, every experience you've had because of the choices you make, creates a memory. And it's recorded in 100 billion neurons and tens, if not hundreds of trillions of connections or synapses, your neural network. And all of your experience are all intertwined in this beautiful tapestry. And Alzheimer's disease comes in, and by destroying the synapses, the connections between these nerve cells, it's like they're pulling that tapestry apart, thread by thread. And as you know, when you pull something apart thread by thread, the more you go into it, the faster it starts to come apart. So there's really nothing worse, because all of these memories you made your whole life, creating who you are and how people know you, are disappearing. It's awful for the patient who is terrified by this. It's awful for the loved ones. It removes the essence of the person. There's nothing worse. Fortunately, drugs are on the way. We're in a golden age right now of Alzheimer's for drugs being on the way, whether they're new drugs or repurposed drugs. The lifestyle shield, goes a long, long way. I mean, when you sleep, your microglial cells eat your amyloid. When you exercise, you make new nerve cells in the part of the brain that's affected by Alzheimer's, the hippocampus. You reinforce it. When you exercise, the muscles release a hormone that goes to the brain and allows an enzyme to be made that breaks down the amyloid, right? So 7,000 steps per day was shown to delay Alzheimer's by 7 years. 3,000 steps by 3 years per day, right? So there's things we can do. But in terms of the brain and what it is and what is Alzheimer's doing, I want to use one example. An infant has the 5 senses going, but that's about it. And an infant sees a red shoe, and it means nothing. The senses bring in the color red, the shape of the shoe, but nothing's in the brain yet to put into context. That's a red shoe. It belongs to mom. You learn that. So now every time you see a red shoe, the sensory information goes into a part of the brain called the entorhinal cortex behind your nose. And then it goes down a path of axons called the perforant pathway, because it perforates the hippocampus, short-term memory. And the hippocampus then says, okay, red looks like that. That's a shoe. It belongs to mom, right? That's learned. In a patient, it's the hippocampus that goes first. So think about it. Eventually, if the hippocampus can't interpret what that red shoe is, you see a red shoe and now you're like an infant again. You don't know it's a red shoe that belonged to mom. We take for granted the context that we give to what comes through our senses to make sense of it and interpret it. That disappears in Alzheimer's disease. You may see food in the refrigerator full of green mold because you forgot about it, but your hippocampus doesn't tell you, oh, don't eat that, right? These are things we take for granted, that we can put everything we see and sense into context based on a lifetime experience. Well, you need the little hippocampus. Hippocampus means seahorse in Greek. It looks like a little seahorse. You need that to have context. And that's exactly what's destroyed day by day in Alzheimer's disease. And that's exactly what our medicines will preserve and promote. And SHIELD is fully aimed at preserving the hippocampus. It really is, from sleep to diet to handling stress, all maintaining that little guy, that little seahorse, the hippocampus, so that you can continue to have context in your life when you experience the world. We take it for granted, but that's what slowly and gradually disappears in Alzheimer's disease. And it's horrible. It's just terrible.
Yeah, it's like you begin to unlearn the world.
I think that's a good way to put it. Yeah.
This losing of context, I get it now, how it has to do with the cognitive part of the brain, losing the ability to make connections, how this context vanishes, and the effect that this has with awareness. And then I'd like to ask you, what has your experience and knowledge throughout your professional and personal life taught you about awareness? How would you define self-awareness?
Now we're getting deep.
Yes, we're going to go deep.
Yeah, that's good. I like it. Going down the rabbit hole. I'm going to get a little metaphysical. What is everything? It's existence, right? Existence is awareness, right? Without awareness, there's no existence. So in medicine, we say that when awareness takes on attention, you're conscious. If you're unconscious, you may have brain activity in your brain, but awareness has to have attention to something to be conscious. So consciousness is awareness with attention. In Alzheimer's, awareness is still there inside. They're still in there. But if the parts of the brain you need to pay attention and focus have been decimated, right, it's affecting consciousness. And even self-awareness requires awareness paying attention to itself. I wrote about this in Superbrain, my second book. In Superbrain, I talk about how self-awareness is a gift we have, that you can be really upset and then step back and say, oh, that's just me being upset. You don't have to identify with the emotion, right? In Superbrain, we taught, don't identify with emotions. Observe them from the mountaintop and figure out how to deal with them. That way you experience the emotion, you're not sterile and cold, but you don't identify with it so you can move on and deal with it. That's what self-awareness gives you. That's what Alzheimer's takes away. So self-awareness is a great, great gift. And to lose that is to lose yourself. It really is.
Okay, so a patient's self-awareness is gone, and then
slowly.
He can
slowly
only
goes.
then exist if she's aware.
They're still in there. They're aware, but because they can't pay attention, eventually the ability to have attention to what they're aware of, whether it's themselves or somebody else, starts to affect consciousness itself. Non-local awareness is in the absence of space and time, meaning pure awareness requires no where or when or place. As soon as awareness takes on attention, meaning you're creating consciousness, that has to happen somewhere, that space. It has to happen sometime. So once you don't have the ability for awareness to pay attention and your consciousness starts to go, you lose track of space and time as well, because space and time require awareness to have attention and consciousness. I know this gets a little deep and metaphysical, but that's how it works, because some would say that space and time were created as soon as pure awareness, some people call it God, call it what you want, took on attention to itself. Awareness took on attention to itself, created consciousness, and then within that, space and time were created, and we live with that consciousness as a universe. But now we're getting really deep in, but yeah.
Yeah. So talking about memories, many of us, I think, reflect on how come in some late stages of the disease of Alzheimer's, patients remember how to play and sing songs, no matter how far ill the person is. 4-time Grammy Award-winning drummer Terry Lynn Carrington mentioned the documentary film Alive Inside. She spoke about it with such warmth and sensitivity that I want to share it with you. Let's listen.
There's a movie called Alive Inside. It's a documentary that I highly recommend because it really shows you, like, there are people in nursing homes that are just kind of withdrawn, haven't moved, haven't talked in months. Then they put Walkmans on, headphones on them, and they've specifically tried to access, or, through their relatives, the music of their youth, the music that they, responded to. And in so many cases, people that hadn't walked, they got up and danced. People that hadn't talked, they sat upright and spoke. So the power of music healing in that way is the evidence is all there.
How is this possible? Where does the brain safeguard music? And what does music do to the brain's Alzheimer's patients?
That's really important. So it turns out somehow, Alzheimer's disease pathology, the plaques, the tangles, the inflammation, spreads through the brain. It goes from the short-term memory area, the hippocampus, through the next area, the temporal lobe, eventually to the long-term memory areas of the frontal cortex. So that's why patients might remember the day of their wedding or high school, but they can't remember what happened 5 minutes ago because the short-term goes before the long-term. But as this disease pathology spreads kind of like in a circle in the brain, in the middle of that circle is music memory, and it stays untouched, just miraculously stays untouched. And music memory stimulates the hippocampus, the short-term memory. So you may have a hippocampus that's no longer being stimulated, to give context to sensory information coming in from the world. But the little circuit that brings music to the hippocampus is still fully intact. So here's a person who may be almost vegetative, unresponsive to the world, and they hear music, and that music memory directly stimulates the hippocampus, and they're alive again, alive inside. It's exactly right. And I actually had an app I started once that you put in your loved one's age and music genre preference, and then it plays for them music that was popular when they were between 12 and 25 years old, because that's the music that most emotionally excites you and can most turn on the hippocampus when you hear it. Now, once all the music sites said you could just pay the same amount of money and just pick which decade you want to hear music from, it kind of, made our little app unnecessary. You could just pick the decade you want to hear and the genre you hear on any music app now. So we didn't need, but this was before all that. But it was amazing, like,
The Spark Memories radio app, right?
yeah, Spark Memories Radio. It's gone now, but it was before. It was ahead of its time. Now you can just do this however you want on Pandora, Spotify, whatever. But I remember the emails I would get back from people using it, and they said, "Oh, my dad has been vegetative. He stays at home. We have a caregiver, and we did what you said, and we knew he liked the song Poison by, I think it was Peggy Lee,
Yeah.
and so we played it for him. And all of a sudden, he sat up in bed, eyes wide open, and immediately started talking about this red pickup truck that he had, that he used to pick up his date to go to his senior prom dance in high school. And then it immediately became very awkward because he went into details about what happened after the dance and the prom with the girlfriend. But they said it was just amazing that he had woken up and just simply because of music.
What a beautiful moment. I've always been intrigued by how experiences, the thoughts, the sensations, and the emotions that define us are encoded in the brain. And if they can really be separated. And there's that spark of magic when we fall in love, when we pray, or when we say goodbye. That space between humanity and something greater. In embodied cognition theories, thought and feeling are deeply intertwined, and yet, in certain neurological conditions, we see emotions linger even when memory or reason begin to fade. In trauma, for example, a person may not consciously recall what happened, but the emotional imprint remains hidden deep in the unconscious. And in Alzheimer's, even when so much is lost, as we just heard, music memory endures. That emotional rhythm that stays untouched. And up next, we will hear Professor Alfonso Caramasa, Harvard's Daniel and Amy Starch Professor of Psychology, and one of the leading voices in cognitive neuropsychology, speaking about a rare condition known as prosopagnosia, a condition that reveals something essential about emotions and awareness, and how feeling sometimes remains even when recognition fails.
Something that comes from a brain damage where there are patients who have lost the ability to recognize a person faces. So there's a disorder called prosopagnosia. Patients who cannot recognize, look at the face, including the face of a loved one, including their own faces in the mirror. However, it has been shown that even when a patient does not recognize explicitly that person, there is an emotional response, and they can measure that. There is an autonomic response that we measure in the person that indicates that despite the denial of knowing who the person is, their emotional system is working. Okay, so we connect then the meaning of these things to our emotional experience and emotional. Now, going back, there is clear evidence that the two can be separated, but that they are part of each other.
I've asked this question from different perspectives to other guests at this season, including philosophers, computer scientists, and neuroscientists. But now I want to hear from you, please. How can someone who cannot recognize the face of a loved one still have a deep emotional response to them? Do you have any knowledge or theories about how this magic works, not only in cases of face blindness, but in general? How are emotions still there, and how are these being processed if the part of the brain supposed to shelter them has been damaged?
Well, we talk about music memory. We know that area is spared. I think what this says is that the parts of the brain that pertain to everything that's not AI about us, the wonder, the awe, seeing a sunset, seeing a beautiful mountain range, and how that makes you feel in the presence of beauty, this is something I don't think can ever be encoded in AI. They can be programmed to react to a sunset, sure. But the feeling you have that a sunset or of someone you love walking into the room gives you, yeah, we know there are neurotransmitters like dopamine and oxytocin involved that moderate that feeling. But that feeling itself that we experience as humans, right, that doesn't go away in Alzheimer's disease. It's still there. I wrote 2 songs as a musician. I wrote a song called Remember Me with the popular singer Chris Mann that talks about how they're still inside, they're still there.
I need someone to hold on for me, to what I can't seem to hold on to. The life we used to live is slipping through my fingertips like a thread that's unraveling. I suppose that nothing lasts forever.
It's a beautiful song.
Oh, thank you. And that proceeds from that song are going to the Cure Alzheimer's Fund for Alzheimer's research. And I wrote another song that I didn't release yet with the very famous composer Desmond Child. Desmond Child wrote most of the Bon Jovi songs and many of the Aerosmith songs. And I've done a lot of work with Aerosmith and Bon Jovi, and with people in Bon Jovi. And the new song that we didn't put out yet is called Somewhere Inside of You. And it's about the fact that you're still there somewhere inside, that I'll just read the lyrics from the bridge of that song.
Yes, please do that.
Yeah, you taught me to dance, you gave me the chance to fall and to spin even faster. When I'm lost in the cold, darkest night of the soul, you always bring me that bright morning after with your laughter. The chorus is, your love gave me pride deep down inside, made me special. You showed me how to care. I know you're in there. I close my eyes, so lost sometimes, and run back to that me and you place we share. I know that I'm still there, somewhere inside of you. In that me and you place we share. I know that I'm still there, somewhere inside of you. And so, at some point, Desmond and I will put this song out there. But I think it captures, along with Remember Me, it's an anthem to patients to say, we know you're in there, okay?
Yeah.
We know you can't show us.
We won't leave you.
But we won't leave you, and we're going to show you all the love you need, even if you can't show us that you know.
How loving and how much tenderness. In one interview I saw from you, you were mentioning emotions could be water and minerals, moving through darkness before a thought or a memory is imprinted in the brain. Let's hear what internationally recognized Italian photographer Domingo Millela, also a fellow guest of the season, says about the perception of the eye, the images he photographs in ancient caves, and how these are encoded in the camera oscura.
I have to say that there is a strange affinity between the images I was trying to photograph on the rock and the images I was trying to do with the analog film, coming back to the body and the analog element of the world. Both primitive images, as much as photographs, are created by minerals and by water. The construction of film requires water and silver minerals. The presence of the image in the cave is surrounded by humidity and water and mineral pigments. Darkness is useful to protect the image in the cave and is fundamental to shelter the image on the negative of the analog camera. And water comes again needed to develop the film, and darkness again. Darkness, water, minerals. So the camera obscura, the eye, and the cave once again seem to be in very close proximity.
So perhaps the magic is in water and minerals. The thoroughly of emotions as well as those captured images is all in the simplicity of water and minerals. Was not Carl Sagan who said we are made of stars?
Yeah, we're stardust.
Well, Domingo Millela, who we just heard, left the following questions for you.
Hello, I'm Domingo Milella. I'm an artist, and I have a question for Dr. Tanzi. I've always been fascinated with the mysterious phenomenon of the so-called terminal lucidity. Strange, odd, unfair, and a bit magic too. Could you tell us more of this riddle?
I wish I could. I'm equally amazed by terminal lucidity, how you can have someone who has shown so little response to those around them, and then at the moment just before death, to be so alive and so awake, and like nothing ever happened, like they were perfectly fine. And, this has been documented so many times. The metaphysical side of me wants to say there's a soul in there that figured out how to shine through despite the gauntlet and the obstacles of a decimated brain. But the neuroscientist in me says, there still has to be a way for the brain to do this. How does the brain suddenly find its way around all this destruction and decimation to do so? And I think it's somewhere in between, that upon death, there's a blast of emotion. There's a blast of who you are. I saw it when my mom passed a couple of years ago. I saw it in her. I saw the point at which she had lucidity. I saw the point which everything was clear to her. I saw it in her eyes. I'll never forget it. It's when I think of her, that's what I see now, And I think that what's happening is that it's not to get corny, but it's love, right? What you most love and are attached to, it burns through, and it finds a way to come through with whatever's left in the brain, whether you're coming out of a coma or whether you have Alzheimer's disease. That's the essence of life. That's the essence of the soul. That's the essence of who we are. It's the essence of why AI will never be us. The feelings of beauty, awe, what's sacred, what you love, cannot be encoded. They can be mimicked.
Professor Tanzi, my second question is, are there any prodigies of the brain in your career that you could share with us? Have you encountered or studied exceptional cases in your career, like people whose brain function in extraordinary ways, perhaps cases in neuroscience that do not have an explanation, and revealed remarkable insights about the brain function or even beyond?
Well, I mean, I've only experienced this lucidity, terminal lucidity once, and that was, on a personal level. But I've heard about many cases from so many people. This gets into the question of what is there beyond the brain and the senses. And we all know the terms ESP and extrasensory perception and telepathy. And some people just say that's all, foo-foo and woo-woo. But I think anyone who's experienced an incredible event of telepathy or ESP that can't be explained, you can't tell them it doesn't exist.
Absolutely.
It's a personal thing. All realizations are personal. Nobody can tell somebody. It's kind of like the old adage of, trying to tell somebody there's a moon and pointing at it and all they can see is your finger. They have to see the moon to know. Mm-hmm. And in my case, I've had many events that I can't explain. Foresight, I've practiced and still do practice lucid dreaming, deliberately waking up in dreams to explore your inner consciousness and ask questions of it while you're awake in a dream. I've had lucid dreams that several times that, where I was in dreamscapes that suddenly became real a week later. I'm not making this up. I mean, it happened, and I don't know how to explain it. And I'm happy that I can't explain it. I know I experienced it, so I know there's something much more than what I was taught as a neuroscience student at Harvard and what I do today. I just accept there's much more. And the thing is this, everything that seems metaphysical and mystical now, as soon as you can measure it and predict it, it becomes science.
Science, absolutely.
Right? At one time, breathing was mystical until we could predict and measure pressures and oxygen, right? So all of these things now that seem like foo-foo and woo-woo and mystical, as soon as someone figures out the units and can predict them and measure them, it becomes science. It's just a matter of time.
Well, many of these phenomena that science still cannot fully explain are considered taboo. Let's listen to what Dean Radin has to say about the most frequent types of individual and collective parapsychological mind-matter interactions that people report. Dean Radin is a leading expert in the field of parapsychology. His research has included studies of individual and collective mind-matter interactions like precognition, clairvoyance, distant healing, and telepathy. He's chief scientist at the Institute of Noetic Science IONS and associated distinguished professor of integral and transpersonal psychology at the California Institute of Integral Studies.
The phenomena that we deal with are all based on experiences that people report. The most common is precognition in dreams. Somebody wakes up from a dream and it oftentimes has a peculiar aspect to it, and then they notice during the day, to their surprise, that what they were dreaming about actually came true. So if it's something that's quite mundane, it's not very interesting. But if it was a surprising dream, and something came true, well, then people will report it. That's how we know about these kinds of experiences. And then other experiences just in everyday life are things like telephone telepathy, where somebody just out of the blue thinks of someone else and a few minutes later they get a phone call. Again, if it's a phone call from a family member and you get one every 20 minutes, it's not so surprising. But if it's somebody that you haven't heard from in 20 years and they call you, and you just thought of them beforehand, then it's quite surprising. So again, we hear about those kinds of experiences. So the experiences that we hear about some of them can certainly be due to coincidence. Others, we're not so sure. And that's where it becomes interesting from a scientific perspective, because we can take simulations of those experiences into the laboratory under controlled conditions and begin to learn, are these actually coincidences or real connections through space and time? From both scientific history and religious history and contemporary, there's an enormous amount of pressure to not talk about these things in public, and that is the definition of a taboo.
Professor Tanzi, you are so generous to speak openly about things that are considered taboo, and you do it in such a great sense of confidence that is really inspiring. I just want to ask you if you could tell us a little bit about your lucid dreams, as well as whether you have been able to use this, let's call it magic now, in our material world?
As a scientist, the first thing you have to say is, I don't know, right? You never say, I know something is not. You just say, I don't know. And you have to also, as a scientist, as I said earlier, know that for anything that seems mystical and impossible and metaphysical now, as soon as you have units of measurement and you can measure and predict it, it becomes science. So like in science, we say, we shut up and measure, right? So it's just a matter of time before anything is telekinetic, telepathic, unexplainable, as Dean was just saying. I know Dean well, and he is the leader in this field for sure. I've been on many panels with Dean in the past, and the work he does is the front runner in this entire parapsychology space. But I like to say there's when I write my books, I have to talk about what's known, meaning science, what's unknown, that's worth trying to know. Okay, meaning work toward it's engineering that allows you to learn how to measure and predict things that now turns a metaphysical aspect into a scientific aspect. That will happen, I believe. I don't know, in my lifetime. That will happen for telepathy and parapsychology. But, it's going to be probably even a little tougher than breathing and electricity when all these things seem magical. I would say, so for lucid dreaming, when I was a kid, I read the books by Carlos Castaneda and later books by Steve LeBerg, who I also know, who named it lucid dreaming. Castaneda called it the art of dreaming. And the idea is that you learn how to wake up in a dream so that you are as conscious as you are right now, but in a dreamscape. And when you first learn how to do this, you're like an infant who's just horrified and terrified by the world around you. You can't put things into context, right? Because it's a whole different mindset. And little by little, as you practice lucid dreaming, you get better and better at putting things into context and staying in the dream. In a lucid dream, as soon as you become emotional, you pop out. As soon as you perseverate or stare at one thing, it's going to morph into something weird, and you pop out. So to stay in, you have to be very quiet, very still, walk very carefully. Don't stare at anything too long, quick gaze. There's an art to doing this. And the art of dreaming by Carlos Castaneda is a more abstract version, more metaphysical version. Steve LeBerg's lucid dreaming is more of a guide on how to do it, but both of them come up with the same ideas. So I would practice lucid dreaming sometimes just for fun, frankly, just to fly or walk through walls or go underwater and be able to breathe, because you do whatever you want in a lucid dream. It's the best vacation you can have, right? But then I use it for science in the past too. And I remember one particular time, before we found the presenilin Alzheimer genes in 1995, we had no idea what these genes were going to be. We knew where they were on what chromosome 14, in the rough region, but we didn't have the genes yet. And we had about 150 different candidate genes they could be. And I remember I had a lucid dream, and this little guy brought me to a walkway that I used every day from my lab to the parking lot and showed me two photographs on either side of the wall that are really there and said, this is what the gene does. So at work, I go and I look at these photos, and I work in the Navy Yard, right? The Charlestown Navy Yard. So these two photos, one was of a mast of a big ship with sailors interspersed going up the mast, hanging onto the mast. The other one was a gateway with two sailors with guns, with bayonets pointing into the archway, one on the left, one on the right. And I said, this is not helping. I don't see how these are going to help me find the gene. Well, today, guess what? Presenilin, when it sits in the membrane of the cell, goes in and out of the membrane of the cell 8 times. If you go to that photo and you draw a line through those sailors on that mast, it perfectly creates the shape of presenilin in the membrane. What does presenilin do? It's an enzyme that cuts on 2 sides of the protein, one from one side, one to the other, in a section within the membrane of the cell. And if you look at that gateway, where the 2 guards have their guns, one on the left, one on the right, with the bayonets pointing out, it's exactly how you would picture the amino acids of presenilin as an enzyme cutting APP, the amyloid precursor protein. So it was exactly right on the spot. But there was no way I could, at that time, not knowing what the gene was, take that information. In retrospect, I can look and say, okay, these photos exactly show me what presenilin looks like and what it does. So how do you explain that stuff, right?
You can't. just at all. Let's hear from Dean Radin one last time on the consciousness states in which these phenomena typically occur.
Some people seem to have more of a facility to access this kind of state. If you look historically about what are the mental states that people are in that produce these kinds of effects most often, it is absolutely not the ordinary conscious waking state. It's in dreaming, with certain drugs like psychedelics, with meditation, with extreme sports. Anything that pushes you away from ordinary conscious awareness seems to be the place where these things show up. There's a huge range of different kinds of skills that people have because all of us have mutations. Some of those mutations may push into the direction for reasons we don't understand very well. So in some respects, it shouldn't be too surprising that some talents are fairly rare, but we don't question that they're real. In this realm, we question that they're real because, as we were mentioning before, a huge taboo that has prevented this from being taken seriously, at least in public, by the scientific community.
Coming back to one of my favorite types of magic, music. Professor Tanzi, not only are you one of the leading voices in Alzheimer's research and multiple times New York Times bestseller author, but you are also an accomplished musician. As we heard, you have played and written music, performing with legends such as Aerosmith, guitarist Joe Perry. You co-wrote this song that you were mentioning, which I said it's a beautiful song. It's an anthem for Alzheimer's patients. Remember Me with Chris Mann. And you also share your music for free online. As a pianist and keyboardist, you play jazz and rock. And it's clear that music isn't just something you study scientifically. It's something you live by, create, and experience. As a musician, you have experienced this connection between memory, emotion, and creativity firsthand. Before I ask the next question, let's hear from Terry Lynn Carrington one last time as she talks about the ability of music to transport her to a timeless spiritual place.
When we play, we're connected to something that makes people move. And I think that's healing, whether they move in time with it and feel that kind of pulse, or a lot of times people just dance freely when they hear something, especially in jazz. So that desire to move is already healing because we're moving away from being stagnant to something that puts us in this universal flow. Even for me, if I have a headache, this has happened to me so many times, and I have to go play, and the last thing I want to do is hit a drum or hear something loud. As soon as I start playing, it goes away. It actually, this is the medicine that's better than taking an aspirin. I don't know, sometimes I guess I would think before that was just mind over matter, because when you play, you are in the present. At least for me, my mind doesn't go anyplace else, which is such a gift, and I think that is a spiritual place.
I've asked different artists about this, and I can help myself but ask you, where do you think creative energy comes from? This drive felt into your body vividly that needs to be somehow expressed, to be captured in time. Can you tell us about the experience and how you sense this energy and channel this kind of ancestral knowledge, or however you want to call it?
Yeah, this really goes also back to what Dean Radin was saying before about intuitive flashes. The circuitry in the brain where we live every day that creates who we are personality-wise, that allows us to make judgments with observations, that allows us to contextualize the world in a specific way that matches our personality. It's called the default mode network. And interestingly, Alzheimer's pathology travels specifically through the default mode network circuitry of the brain. And when you use the default mode network, which is when you're not creative, you're not being creative, you're not improvising, you're not focusing on a task, whether it be a sport or a hobby or music. The default mode network is where amyloid forms with neural activity, most earliest in the disease. So I always, in my book, in the new book, I'm going to talk about turning off the default mode network. How do you turn it off? a hobby, focus on a hobby, a task, could be gardening, a sport. Anytime you're mindful, you're engaged, you're not just perseverating or thinking about the future, maybe with anxiety, or thinking about the past, maybe with some obsessiveness. You're not judging yourself or others. The default mode network is turned off. So for a musician, if I play rock like I did on the albums with Joe Perry from Aerosmith or on the last Aerosmith album, I'm thinking more about improvising, right? More about going into that, turning that default mode network off and going into that timeless, spaceless part of the brain where you can create. And why Joe Perry and I became such good friends is we both agree that the best music is non-derivative and comes from you play from intuition. You don't play from cliche or preconceived notions, right? That's what the default mode network would give you. You get out of that, right? My hero in music is Keith Jarrett. Keith Jarrett invented extemporization, improvising extemporaneously, sitting at the piano. He has no idea what he's going to play. The audience is there, and off he goes. So my music online, and I'm no Keith Jarrett, but my music that's online on n1m.com is my Keith Jarrett attempts, my extemporizations. I sit down and I play, and depending on what's going on in the world, whether it's the hostages in Israel or what happened in the Ukraine or the pandemic, I let it take me over and clear my head and play. And I name the songs accordingly. I'm fortunate. I don't charge for it, of course. I'm not a professional in that regard. But I get about 30,000 listens per day on my site, which probably is more people than read my scientific papers. And but that for me is like, that is medicine. It's exactly what we just heard. Anytime you can do anything that's creative and mindful, where you're escaping the default mode network, you can breathe more easily and you basically turn off the parts of the brain where Alzheimer's disease spreads. You should try to do this every day, do this all the time. Mindfulness and doing things that take you out of yourself, where you're not thinking about the future, you're in the moment, you're in the present, you're not judging, because we judge every day, we can't help it. It's part of who we are. And that's what hobbies and creativity do for you. And music is a wonderful way to do it. But it can be anything. It can be any skill or hobby or thing you like to do, where you're in the moment and you're focusing and you're free of everything that would otherwise control your personality.
I really think artistic and musical expressions can also be powerful ways of tapping into the source of creative energy, as you're mentioning, to that big, the whole awareness, a path that may allow us a transcendental experience. For our last question, we'll hear the voices of Magnum photographer Gregory Halpern, mezzo-soprano Marina Biotti, cellist Andre Ionitsa, abstract painter Cecilia Rivera, and British orchestral conductor Karim Hassan. They reflect on art expression and on the blurring of time and space in artistic and musical expressions.
When I think of making pictures, for me, it's more about really evoking feeling and creating something very open-ended that the viewer can bring themselves into, create space for them to bring themselves into. And so for me, when I think of like a literary equivalent, it's maybe closest to poetry.
Well, when I sing opera, I am a character. I'm part of a story. So I'm not Marina. Just before I enter the stage, I kind of imagine myself the whole backstory of a character, how she will walk, how she will react. Is she naive or strong or soft? When I am on stage, I forget everything about myself, about me, and I am this character in this story, and I am delivering a text and an emotion. I kind of transcend the person I am and become this ambassador or this vector of kind of a higher purpose, or at least something that will reach people's hearts.
Your deepest thoughts, even the ones of the unconscious, do come through because you're not sort of completely in control anymore. That's the fascinating aspect about performing. One should also be able to sort of double themselves, have this sort of overlook from above while performing, in the sense of anticipating what's coming next, always remembering yourself to breathe. to feel as grounded as possible, to find your center of gravity.
What I try is to depict the world that I imagine. What you see, what you not see, the realities we create. And those vibrant colors, men dancing and interacting, going in and out, represent those dimensions, interacting continuously in our lives.
One of the greatest composers to really take you on a musical and a harmonic journey is Johannes Brahms. His symphonic writing is so extraordinary and takes you on such a complex, nuanced journey that every time you come back to these symphonies, you are discovering something new. And it's astounding because his music is so compact in a way that there is so much information. It's like taking a microscope. You can zoom in onto the individual bars, onto moments within a bar, and find some really, really interesting information about the harmony or about the way that the motifs relate to themselves. And then you can zoom out and look at the way that entire movements connect together.
With everything that we have talked about today, my last question would be, how would you describe consciousness and what is its relationship to the brain?
Well, I tend to believe that everything is consciousness. I'll say something that's very taboo because it's what I believe. As a scientist, the idea that there's a magical house called the universe with trinkets that are material floating around and they came out of nowhere, and it's actually a material world that came out of nowhere. How can I say that as a scientist? Oh yeah, it came out of nothing, out of nowhere. That's fine. No, I tend to believe that everything we experience in the universe, including the material world, I can knock on my desk. Okay, in a lucid dream, I can knock on a desk and feel something material, right? But it's all in consciousness. It's possible to experience the material world in consciousness. So I will say something taboo. I believe that the entirety of existence, including the universe, is an awareness. That awareness with attention creates time and space, as we talked about before. And that everything is consciousness. I personally don't believe there's a material world. That everything exists in consciousness. And that you have higher and higher ordered assemblies of information that are interacting, that we are aware of with attention, creating consciousness, but everything is within consciousness, including being conscious. So to me, that's easier to believe as a scientist than to try to say to myself, there was spontaneous generation of material out of nothing. That can't happen. So even the universe, the material world we experience is all within consciousness, in my opinion. And I think it's beautiful that, where we ended here, because what is destroyed in Alzheimer's disease is the default mode network, which is where we live when we're not being creative, intuitive, and mindful. And I would give anything to see inside of the mind of an Alzheimer's patient where that default mode network and who they are and their personality that's encoded within that default mode network has been destroyed, setting them free inside to be the most creative entity probably in the world. I can only imagine in the mind of an Alzheimer's patient who can't express it, the beauty and the creativity that's going on in that mind, free of the restraints of the default mode network and the personality it imparts upon a person.
Professor Tanzi, you are an amazing scientist, but moreover, an incredible, generous human being. Thank you for your generosity in giving us so much of your time, for your ongoing fight against Alzheimer's, for your wonderful discoveries, and that fantastic creative energy that enables you to think outside the box. Please keep making breakthrough science, creating wonderful music, and doing so much good for the world. Your work means the world to millions. It was an honor and a pleasure, sir. Thank you.
Thank you, Ceci. I enjoyed it immensely. Thank you.
Thank you to our listeners wherever you are for having allowed us to share time with you. Shall you wish to check out Professor Tanzi's work, books, papers, or would like to contribute to the amazing research performed by the Cure Alzheimer's Fund Research Leadership Group, to which he serves as chair, please do not forget to check the links we have made available in this episode's description. For free access to Dr. Tanzi's music, go to n1m.com and look for Rudy Tanzi. See you next time. Bye-bye.